Hi, welcome to The Revolution Will Be Spoken, adding speech to your web app. My name is Scott Davis. I'm a web architect and developer advocate with ThoughtWorks. I've been doing web development for about 30 years or so at this point. This is something I am truly, deeply passionate about. So, let's take a look at trends in modern software development. And based on the title of this talk, I don't think that you're going to be surprised at what we're going to find. It's easy to focus on how nice a website looks, especially for novice developers and non-technical users. But it's also painfully easy to spend a considerably disproportionate portion of your overall attention on look and feel issues when there is so much more to consider. It's so easy to fall for this myth that the user experience is only about visual design. What other senses do your users use when they're visiting your website besides their eyes? Can they listen to your website? Can they talk to your website? Can they pinch and stretch with their fingers, pull down to refresh, and swipe right? Does your website buzz with haptic feedback? There's a lot going on with your website, far beyond what those little eyeballs can appreciate. So, let's see what Gartner has to say about the top 5 digital technology trends for 2020. Spoiler alert, 4 out of 5 of these trends are directly related to voice. And oh yeah, the 5th one is too. Gartner just didn't realize it. We're going to talk about multi-experience. We're going to talk about interfaceless machines, agent interfaces, facial recognition. Yeah, that's the one that's about audio as well. And inclusive design. Trend number 1 is multi-experience. We want a consistent and unified user experience across all of our devices. Laptops, tablets, smartphones, wearables like smartwatches and earbuds, smart speakers, and even smart TVs. You see, these new kinds of devices are driving new modes of interaction beyond keyboards. Because where are you going to plug a keyboard into a smartwatch or a smart speaker? Where are you going to plug a keyboard into a smart TV or your AR, VR glasses? Voice is such an obvious way to interact with these types of devices. Trend number 2 is interfaceless machines. How many electronic gadgets do you own that simply have no user interface? Earphones? Smart speakers? Heck, I have a couple of kitchen gadgets that end up in ovens and grills and pots of boiling water. And if you don't believe that this trend has anything to do with web development, say, "Hey Alexa, Wikipedia Carrie Fisher," and let me know how that Wikipedia webpage sounds. Trend number 3 is agent interfaces. Now, you know that web browsers are often called user agents, right? Because those browsers do all of the heavy lifting of making HTTP requests, DNS lookups, downloading security certificates, managing the cache, and so on and so on and so on. All of this on your behalf. Well, conversational UIs like Alexa and Siri and Cortana are all agent interfaces as well. But they rely on the spoken word instead of tapping on a keyboard, jiggling a mouse, or swiping on a handheld piece of glass. Trend number 4 is facial recognition payments. Now, I'd like to humbly suggest that this trend is about neither facial recognition nor payments. What it's really about is how hard it is to type in written Chinese. Now, when typing is difficult, different interfaces naturally emerge. Maybe a QR code here, maybe some facial recognition there, and oh yeah, conversational UIs. Conversational UIs are really popular in countries like China and Japan and South Korea, whose written language isn't comprised of a small number of letters like English or Spanish. You see, the characters in written Chinese represent syllables and sometimes entire words. Writing in English is more like a simple addition problem. This letter plus that other letter make up a word. You see, educated Chinese words have to memorize upwards of 4,000 unique characters. That's one big honking keyboard, isn't it? So, the complementary systems that emerge to efficiently deal with the Chinese language involve cameras and microphones and, yeah, agent interfaces. And trend number 5 is inclusive design. Now, inclusive design usually comes up when we're talking about folks with disabilities, but really it means serving the broadest possible community of users. I like calling this universal design because you and I end up using features that were originally created for folks with disabilities all the time. For example, how many of you have your phone in silent or vibrate mode? Uh-huh. And how many of you are deaf or have a hearing loss? Yeah, see what I mean? The explosion of conversational UIs is simply an accessibility feature that has broken through to mainstream success. It was originally designed for folks with blindness or low vision, but how many of us use these features today? Look at those highlighted numbers for voice search usage. 50% of all internet searches in 2020 are voice-based. 40% of adults use voice search at least once a day. 9% of folks aged 55 to 64 do too. And over half, 55% of teenagers use voice search every day as well. A quarter of all Android searches are voice-based. See what I mean? This is inclusive design that we're talking about. We need to build our apps not just for some of the people or even most of the people. We need to build our apps for all of the people. So, let's see how deeply integrated voice can be to the computing experience using nothing but commercial, consumer grade, off the shelf hardware and software. This video from Apple does a great job of demonstrating what this looks like today, here, right now.
Wake up. Voice control is a breakthrough feature that gives you full control of your devices, with just your voice, period. It's a whole new way to do everything you love, period. Like this. Correct love. 16. Open photos. Scroll up. Show numbers. 13. Click share. 3. Tim. Next field. Let's ride this one today. Thumbs up emoji. Click send. Open map. Show grid. Long press at 20. Open app switcher. 4. Tap share. Tap Tim. Tap send.
Hey, good to see you.
Open music. Turn up the volume.
All right.
All right. Let's dig in and see some speech synthesis in action, or as it's commonly known, text-to-speech. Later on, we'll look at the opposite, speech recognition or speech-to-text. Speech synthesis has been around for a long time, like almost 100 years, as we'll see in just a moment. But the mechanics of speech synthesis are pretty straightforward. For written English, we can take a string of text and split on the spaces to give us individual words. This is called tokenization. Once we have words, we can look them up in a dictionary that tells us precisely how they're supposed to be pronounced. And then we can synthesize the spoken word and pump it out to a speaker or a set of headphones. For written English, we break things down into words and individual letters. For spoken language, we break things down into phonemes. For example, the words sin and sing end with two different sounds or phonemes, n and ning. Once you start digging into how words sound, you start finding some really fascinating relationships between letters that you may not have considered before. Like the relationship between the letters P and B. P is unvoiced. Only air passes between your lips. Pa, pa. B goes through the same motion of your lips, but it is voiced. Ba, ba. The same relationship holds true for letters like S and Z, s, s, z, z. For letters T and D, t, t, d, d. And letters like F and V, f, f, and v, v. Interesting, isn't it? When you listen to the letters being spoken instead of reading them on the page. And here's where things get interesting. Once you understand the rules of phonemes, voiced and unvoiced, lips, tongue, and teeth, you can create a machine that replicates the sounds that we silly humans make as we speak. An inventor named Homer Dudley, back in 1939, created something that looked like a pipe organ, but instead of playing music, it played speech. He demonstrated it at the 1939 World's Fair. I love that this diagram begins with an idea in the player's head. From there, she uses keys and pedals to synthesize speech. Let's hear Homer Dudley's voder or speech synthesizer in action.
The machine uses only two sounds produced electrically. One of these represents the breath. The other, the vibration of the vocal cords. There are no phonograph records or anything of that sort. Only electrical circuits such as are used in telephone practice. Let's see how you put expression into a sentence. Say, she saw me, with no expression.
She saw me.
Now say it in answer to these questions. Who saw you?
She saw me.
Whom did she see?
She saw me.
Did she see you or hear you?
She saw me.
Now, let's flash forward in time 80 or so years and see speech synthesis in action in a modern browser. So, in order to really appreciate speech synthesis, I think we should just head over to any modern browser and see it in action. So, I'm going to click on this Read Intro button, and I'll give you 3 guesses as to what's going to happen next. Let's find out.
No kneading required. 4 simple ingredients, baked in a Dutch oven. The result is simple perfection, hands down the best bread you'll ever eat. The simplicity of this no-knead bread is what I love the most, and the fact that your entire house will smell of fresh bread as you bake this. This bread could not get any easier. It's even easier than the artisan bread.
Notice that it really only takes us 2 lines of code to synthesize speech in a modern browser. 1 line to create a new speech synthesis utterance, and another line to have the speech synthesis API speak it. And more importantly, notice that we didn't have to download a library or a framework to get this to work. The speech synthesis API is baked into every modern browser. If you've never been to caniuse.com, I highly recommend checking it out. It gives us empirical data on which features are supported by which browsers. As you can see here, the speech synthesis API is supported across all major browsers and has been for years. But for more sophisticated speech synthesis, we need to reach for a purpose-built solution, SSML, or Speech Synthesis Markup Language. We use HTML for hypertext markup language, so it only makes sense that we would use SSML for speech synthesis. SSML is what Siri and Alexa and Cortana all use. But SSML brings something really important to the party: emotions. Of course, we don't call them emotions in linguistics. That would make your life far too easy. We call this phenomena prosody in linguistics. Things that aren't typically represented in the written form, things like intonation or stress or rhythm. Prosody is what makes it so hard to figure out irony or sarcasm in text and emails when it's so easy to hear it clearly when you're listening to the speaker. Here's a great example of the power of SSML from Google's documentation. Notice the say as element. That allows you to control how acronyms are spoken, each letter spelled out or pronounced as a word. It would be strange to ask someone how much RAM they have on their new computer, of course, instead of pronouncing it RAM. But it would also be weird to ask how fast their kapoo is instead of pronouncing it CPU. Similarly, with numbers, you can have them spoken as cardinal numbers like 1, 2, 3, 4, as ordinal numbers like first, second, third, fourth, and even spelled out. Because how weird would it be to tell someone that your phone number is 303 555 1212 instead of 303 555 1212? So, knowing that, how do you think Cortana would be able to give you a daily briefing? So, now that we've seen text-to-speech, let's give you a little insight into what it takes to achieve speech-to-text. Let's revisit our no-knead bread recipe. Last time, we used speech synthesis to read the introduction to us. This time, I'm going to click on the other button and see if speech recognition will work out for us. If the great demo gods are smiling down on us right now, you should be able to say either ingredients or instructions and have that section read back to you. As we'll discuss in just a moment, this demo currently only works in Google Chrome. But it is a W3C standard, so hopefully sometime soon the other browsers will catch up with Google in this regard. All right. We saw speech synthesis in action. Now we want to see speech recognition in action. So I've got another button here, request section to be read. I should be able to say ingredients or instructions and hear it in action. Let's find out. Ingredients.
3 cups all-purpose flour, 1 3/4 teaspoon salt, 1 2 teaspoon active dry yeast, 1 2 cups water room temperature.
Instructions.
In a big bowl, mix the flour, salt, and yeast together. Pour water into the bowl and using a spatula or a wooden spoon mix it until well incorporated. Cover the bowl with plastic wrap and let it sit on your counter for 12 to 18 hours.
So, there are a few more lines of code here for speech recognition than there were for speech synthesis in the previous example, but hey, it still all fits onto the same slide, doesn't it? So you can see we begin by creating a new instance of a speech recognition object. Once the process is started, we'll get the written transcripts back in the result event. And with a bit of simple if-else logic, we can have the browser read the appropriate sections using the speech synthesis API that you already know. So, visiting caniuse.com again, we can see that support for the W3C standard speech recognition API is limited to only browser manufacturers who have wired up their cloud services for speech-to-text to their front-end browser. And sadly, that listing for Microsoft Edge is a false positive. Only Google browsers are currently wired up to use Google's cloud services. When Microsoft adopted Chromium for the core of the Edge browser, they neglected to wire the Microsoft Cloud services up to their own browser. So as you can see, Apple and Mozilla need to do the same thing for their browsers as well. So the standard is in place, and we have at least one browser that supports it. This means that once the other browser manufacturers catch up, this promising API will have a proper vehicle for you to use. In the meantime, you can write a polyfill that allows your browser to use a commercial cloud service, or you can look into the Mozilla Deep Speech project for a free and open source speech-to-text engine that you can host yourself. As I just mentioned, Mozilla Deep Speech is an impressive free and open source speech recognition engine. While it's not hosted in the cloud, you can host it yourself and then use it just like you'd use any of the other commercial services. If you are concerned about privacy or would like to deeply customize the speech recognition engine you're using by training it exclusively on your voice and your speech patterns, Mozilla Deep Speech is definitely worth looking into. So, now you've seen how easy it is to handle speech recognition in the browser, or at least in browsers like Google Chrome, whose development team has wired the client-side speech recognition API up to a corresponding cloud service. Here is a real-world example of how you can use speech recognition, in this case for closed captioning. In 180 lines of code or so, most of which I'm happy to report is the HTML you see on screen for the instructions, we've wired up Google's browser-based speech recognition to Zoom's closed captioning service. The next time you're hosting a Zoom call, head over to littlepath.org and turn on closed captioning for yourself. Unfortunately, only the host of the Zoom call can turn on closed captioning. When you copy the link to the client API key for the current Zoom call that you're in and paste it into littlepath.org/zoom-cc, you should see closed captions start to appear on the screen. You should also be able to turn on the transcript sidebar in Zoom. All of the code for LittlePath is open source, so please be sure to swing by github.com/littlepath and check it out. But wait, there's more. What if we could have Alexa read and understand American Sign Language? Thankfully, someone has already done that for us already. I love this video because it brings everything that we just learned together into a single working example. Once we can convert sign language into text, we can then use text to speech to talk to Alexa. Alexa hears our synthesized speech and then sends it to the cloud for speech to text analysis. When the SSML response comes back from the cloud, Alexa uses text to speech to say it out loud. Of course, we need to convert that synthesized speech back into text so that we can display it on screen for our deaf and hard of hearing users.
Alexa, hello.
Hi there.
Alexa, what is the weather?
Right now in New York, it's 29 degrees Celsius with partly sunny skies. Today's forecast has lots of clouds, with a high of 34 degrees and a low of 24 degrees.
Alexa, what is 5 feet in meters?
5 feet is 1.5 meters.
Alexa, what is the time?
The time is 3:33 p.m.
Alexa, add eggs to the list.
I added eggs to your shopping list.
Alexa, tell me a joke.
Did you hear about Golf's new superhero? His name is on the Green Lantern.
Alexa, bye.
Bye for now.
So, if you want to see some very real-world examples of how this technology is being put to use, look for the YouTube series The Age of AI, hosted by Robert Downey Jr. Episode 2, Healed Through AI, specifically deals with speech recognition, speech synthesis, machine learning, artificial intelligence, and all sorts of interesting things. So, what have we learned today? We've seen that it's so easy to fall for the myth that the user experience is only about visual design. As we've seen, there are so many more deeply fascinating ways that your users can interact with your website. Limiting it to just the visual experience is, well, limiting. Gartner showed us that the top 5 digital technology trends for 2020 all ask us to think beyond visual interfaces. Think about interfaceless machines. Think about agent interfaces like Siri, Alexa, and Cortana. And most importantly, think about inclusive design. Because what we've been talking about today isn't future technology. It isn't technology that'll be coming down the pipeline in the next decade or so. Voice interfaces are right here, right now, using nothing but commercial, consumer-grade, off-the-shelf hardware and software. Which is why I'm fully convinced that the revolution will be spoken. And I hope you are as well. Thank you so much for your time today. I hope you enjoyed yourself. I certainly did. Looking forward to talking with you again soon.